So when we're multiplying with the same base, we end up adding the exponents. What happens if we had something like x to the 7th over x squared? Well, on the top part of this fraction, this would just be like having 7 different x's. 1, 2, 3, 4, 5, 6, 7, all multiplied by each other. On the bottom part, this would be having 2 copies of the x. And so when we do some cancellation here, what ends up happening is that x cancels with that one, that x cancels with that one. We end up having, well, it looks like the 7 minus the 2, we end up with 5 x's left over. That's what this rule says. If we have a to some variable, or a to some exponent, and divide it by a to a different exponent, we can figure out how many copies of that a we have left over up top by just doing subtraction. So a to the 7th minus, or divided by a cubed is going to be a to the 4th, because 7 minus 3 is 4. Notice I kept the a the same. This is not 1 to the 4th. When I'm doing my cancellation, I'm getting rid of some of the factors. I'm getting rid of 3 of the factors on the bottom and 3 of the factors on the top. There's still 4 factors of a left over up top. Just like on this one. 5 minus 3 is 2, so this would be the same thing as 4 squared, which is 16. Now, I could have said that this is 4 to the 5th is some number, and 4 cubed is some other number, and did the division there. I'll go ahead and actually do that. 4 to the 5th is some number. It's 1024. 4 cubed is some number. It's 64. And so when we take 1024 divided by 64, we end up getting 16, just like this. Alright, if we have 2a to the 6th over 2a cubed, or 6a to the 6th over 2a cubed, rather, probably the easiest way to look at this sort of a problem would be to split it up and think of it as separate fractions. So I would actually recommend thinking of it like this. 6 over 2 is your first fraction, and a to the 6th over a cubed is your second fraction. So 6 over 2 is 3, a to the 6th over a cubed, 6 minus 3 is 3. So we end up with 3a cubed here. So this kind of allows us to split up the fraction using each of the individual parts. Thinking of it like this. I know that I can do this because that's just my rule for multiplication of fractions. If I have this fraction times that fraction, I would end up taking all the tops multiplied by each other. That would give me this, and all the bottoms multiplied by each other, which would give me that. So that's why I know I can do that. But ultimately, this gives me 24 over 6 here. That would be negative 4. M to the 7th over m squared. 7 minus 2 is 5, so we get m to the 5th. And n to the 4th over n to the 1st. Remember, you can put a 1 there. This would be n to the 3rd. Alright, on this one, we have negative 12 over 4. That's going to be negative 3. M cubed over m squared. 3 minus 2 is 1, so this would be m. Really, it's m to the 1, but you would probably just write that as m. And n to the 5th over n squared. 5 minus 2 is 3. We get n cubed. Something like this, we would want to split up as separate fractions, but it's actually a little bit different than these other ones because you'll notice there's addition and subtraction on the top part of this fraction. And we actually need to use our rule for adding and subtracting fractions for this one. And the rule for adding and subtracting fractions says that if we had something like this, minus 8x to the 4th over 2x squared plus 6x cubed over 2x squared. If we had the same denominator in all three of these, we'd be able to combine the numerators together and have it all over that one common denominator. That's what the rules for fractions, adding and subtracting fractions, say. And so we're just kind of going the other way. We're splitting it up as several different fractions, because then each of these fractions we could then reduce. We could see that there's a common factor, or between the 4 and the 2, we could cancel out a 2 to get a 2 there. X to the 5th over x squared gives us x cubed. 8 over 2 is 4. X to the 4th over x squared is x squared. On this one we have 6 over 2 is 3. X cubed over x would be, x cubed over x squared. 3 minus 2 is 1. This would be x to the 1st power, which would just be x. So this is what we'd get for that one.